I am Suma, lecturer in computer science, working for TSWRDCW, Karimnagar. Today I would like to explain you what is data structure and what are the different types of data structures we have. Coming to the formal definition of a data structure, it is a way of organizing and managing and storing data elements. That means we are going to store some data, we are going to organize them and we are going to manage them. So by this organizing and managing different data elements, we can have efficient access of these data elements and we can also modify the data elements. So in order to understand the formal definition, let us look at a normal illustration here. Here we are able to see few plates which are kept one on the other. We are having 6 plates here. So we have to consider each plate as a data element. So we have 6 data elements here. Suppose we want to pick up the first plate, we can directly access that and take out the first plate. And suppose we want third plate, we have to remove first plate, second plate, then only we can have the access to third plates. In the same way, if we want the last plate which is at the bottom, we have to remove all the plates which are placed above the last plate. So we are organizing these data elements which are in the form of plates in this model, in which access of any data element leads to removal of its top plate. And next, if we consider these chairs as data elements, from left to right, if we name them as 1, 2, 3, 4, 5, if we want to access first chair, directly we can go and sit in the first chair, second, third, fourth and fifth. Without moving any of the chairs, we can access all these chairs. So this is a way of organization of data elements in which no data element is disturbed if we access the data. So there are different ways of organizing data. Coming to the classification of data structures, data structure is divided as linear data structure and non-linear data structure. Under linear, we have arrays, stack, queue, linked list, and in non-linear data structure, we have graphs and trees. So let us see what are these data structures. In each type, how the data elements are organized and how we are going to access data elements in each of these data structures. Coming to linear data structure, by listening the name itself, we can understand that linear means sequential. That means the data elements are organized in a sequential order. All the elements will have one successor and one predecessor except the first and last elements. So in order to understand this point, we have to see the examples of linear data structure. So when you see this linear data structure called array, each block is containing a data element. Consider second, third and fourth block. Each block will be having one predecessor and one successor. And when you consider this first block, it will not have the predecessor, but it is having exactly one successor. When you take the fifth data element, you can see that it is having one predecessor, but it is not having any successor. So this linear data structure, all the elements will be having exactly one predecessor and one successor except the first and last data elements. This is an exception. The next linear data structure is stack. So in this resembles a bottle with one side open mouth. So, from this bottle we can understand that element 1 is stored first, element 2 is stored next, element 3, 4 and 5 are stored in that order only. Suppose we want to pop out, that means suppose we want to take out the element 5 will be the first element to pop out. After removing this 5 only we can remove 4. After removing this 4 only we can go for 3 and so on till the stack is completely empty. So, if you observe that fifth element is last into the stack. It is last in, that is why it is first out. So, the strategy which is followed in stack is last in, first out. And what is the first element which is in to the stack? It is 1. So, one data element will be last out. 1 can be removed last only after removing all the elements above it like 5, 4, 3, 2 and 1. So, this is one type of linear data structure. Here also you can observe that the elements 2, 3, 4 are having exactly one and only one predecessor and one and only one successor. And you have an exception for the first and last elements. First element will not have predecessor and the last element will not have successor. The next linear data structure is queue. It resembles a pipe. It is same as stack, but the difference is it will have two ends like a pipe. From one end we will insert the elements and the other end is used for deletion. So, the left side part is used for inserting and the right side part is used for deleting the elements. So, by seeing this diagram we can say that 31 is stored first, then C, A, 3, 12 and D, all these are inserted in this order, and while deleting we have to delete through the other end. That is why first we have to delete 31, then only we can delete C, then only A, then only 3 and so on till the end of the queue. Important point in queue is insertion is done at one end and deletion is done at the next end. So, the strategy which is followed by queue is first in, first out. It means that the element which is first in into the data structure called queue is first out. And if you observe all these elements 12, 3, A, C all are having exactly one predecessor and one successor, and the first element 31 does not have the predecessor and the last element B does not have successor. All the remaining elements are having exactly one predecessor and successor. So, this is one more example of linear data structure. Next we have linked list. Linked list will have node. This node is divided into two parts called data and address. Data contains data element and address contains the address of the next node. So, if you observe this singly linked list, the element 10 is having the green color part. This green color part consists of the address of next node which has the data 20, and the address part of this node which contains 20 will have the address of 30, and 30 node will have the address of 40. That means we are establishing links between all these nodes. That is why these are called as linked lists. So, here also you can observe that all the elements except first and last will have exactly one predecessor and one successor. So, this is an example of linear data structure. Then comes non-linear data structure. That means the data elements are not arranged in a sequential order. They do not have exactly one successor and one predecessor. You can have no successor, no predecessor, or many number of successors and many number of predecessors in non-linear data structure. So, to get a clear idea on non-linear data structure, let us see the examples. Here is an example of graph, and all these 1, 2, 3, 4, 5, 6 are data elements. So, they do not have single predecessor and single successors. That is why this is an example of non-linear data structure. You can observe that the elements are not organized in a sequential manner. The next example is trees. In this example, if you take the data element 1, does it have a predecessor? No, but it is having 2 successors, 2 and 3. When you take the data element 5, it is having the predecessor as 2 and it is having 3 successors, 6, 7 and 8. So, the number of successors and predecessors are not exactly equal to 1 in non-linear data structures. By this also we can understand that the data elements in tree also are not linear. That is why these are called as non-linear data structures.